Hello everybody, my name is Mike Guy, and in this video we are going to be looking at basic animation in Allegro 5. In our previous video, we looked at loading a bitmap into our memory and then using some transparency function to get rid of the background, or loading just a transparent background or bitmap into our program to use. Now we're going to take it a step further in this program, and we're going to go ahead and add ourselves some rudimentary animation. Now we will need to create a few variables here, but first let's look at what I have open. I have just my standard Allegro H. I'm now using timers, so I have my timer here, just initializing some add-ons, registering my timer source 60 frames a second, and then I just have my Allegro event timer. Alright. So the first thing I'm going to do is I'm going to create myself some variables that will allow me to keep track of my animation. Effectively, to achieve animation in Allegro, what we're going to do is we are just going to show a series of images, one right after the other, and it will look fluid. It will look like animation or actual motion is occurring. Just so you know, it takes exactly or approximately 12 frames a second to trick the eye into thinking it's seeing animation. We are going to go a little bit faster than that, but we can take a look. What I have, if you recall the image I used last time, it was that blue dragon, whatever. That blue dragon actually comes from a whole series that I got from that website of motion. And that website is, just to give credit where credit's due, right here, reinerstylesets.de, and that's where I got those images. And there's a whole, sheet of different animations and whatnot. So we are going to go ahead and load a whole animation series into bitmaps, and we're just going to show them in sequence. So our variables to keep track, first thing I want to do is I want to do a constant int max frame. That's going to tell me exactly how many frames of animation I'm working with. I'm going to work with 8 frames of animation, starting at 0 and all the way up to 7. So 8 frames of animation. Next, I need a way to know what frame I'm currently on. That I need a count to count the total cycles or ticks or iterations since our last animation change, and I need to know what my delay is. So if I want my animations to happen faster, I'm going to set this to a lower number. If I want it to happen slower, I'll set it to a higher number. I'm going to pick 5 because that makes for some nice even animations with this particular sprite set. It might be different for different animation sets, but for this one, 5 works out just fine. Alright, great. Before, we created our bitmaps and we loaded them into a single Allegro bitmap variable, just one bitmap. Now we're going to go ahead and create an array of bitmaps. We do an array so that we can programmatically iterate through them. If I had just individual bitmaps, I'd have to have a whole bunch of ifs and whatnot to keep track of animation. So I'm just going to do an array. So during runtime, I don't need to know where I'm at. I'm just going to cycle through the array automatically, and I don't have to worry about it. So I'm going to create Allegro bitmap pointer. I'm just going to call it image, and my size is going to be max frame. Great. So I have an array of images, or array of bitmaps named image, that'll be max frame, so 8 in size. Note this, if you're not familiar with C++, if you don't declare max frame as constant, you can't use it as an index size for an array. So just a quick heads up there. Alright. Then what I want to do is, after I initialize my image add-on, I'm going to go ahead and load those images in. And this unfortunately, and we'll look at fixing this later, this unfortunately is a little time consuming because I got to do this manually. So I'm going to do L load bitmap, and I will pass in the file, which is flygt space w1234.emp. Alright, great. And I'm just going to do some copy and paste here, so I have to do this 7 more times. Okay, great. So that'll load all 7 of my bitmaps in there. You can go to that website to get these bitmaps yourself, or you can make your own, or find your own, or whatever. But these are just what I'm using just for demo purposes. And since I'm loading bitmaps into memory, I'm going to come down to the bottom here, and I'm going to go ahead and make sure they get deleted so I don't have a memory leak. And I'm going to use a for loop. And I'm just going to iterate through my array, deleting each individual image. Alright, great. Okay, so far we have loaded our images into memory. Just because I can, I'm going to do for int I equals 0, I is less than max frame, I plus plus. And I'm going to go ahead and call al convert mask to alpha, because we know how to use transparency now, so why wouldn't I? And I'm going to do image sub I is my image, and then my mask color will be al map RGB, and I'm going to do 106 76 48. Great. Awesome. So I'm going to recap here. We have 4 variables for keeping track of our animation. We've loaded a total of 8 frames into memory. We have cleared the background out of those, and at the very end we are deleting them. So all that's left to do is to update our animation inside of our timer, our system update if you will, and to go ahead and draw these. So I'm going to come down here inside my Allegro event timer, so this is the one that's going to fire off 60 times a second, and I'm going to say if plus plus frame count. So every cycle, remember frame count starts at 0, and when frame count equals frame delay, it's time to go to the next frame of our animation. So I'm going to do if plus plus frame count, which will increment our frame count, is greater than or equal to frame delay. If that happens, then I want to increment my current frame. But I got to be very careful not to go beyond the bounds of my array. So I'm also going to say if plus plus cur frame, which will increment my current frame. So if it's 0, it'll go to 1, right? And then it will check after incrementing. It'll say, hey, I just incremented. Now let's see, is current frame greater than or equal to max frame? Remember, we don't want it to be equal to a max frame because it's a 0-based index. So if I have 8 frames, it goes 0 to 7. I never want it to equal 8, or else I'll be out of bounds. If that happens, current frame is going to equal 0. And then finally, since our frame count was greater than or equal to frame delay, I'm going to set frame count back equal to 0. This is the meat of animation. We're keeping track of some amount of time, and we're updating our current frame variable so that we'll know what to draw. Speaking of, I'm going to come here. This isn't going to look much different, if not any different than what we've seen before. And I'll draw a bitmap. The only difference is I'm going to not be drawing image, but I'm going to be drawing image sub current frame. And then some location. I'll just do 200, 100. That's worked from here in the past. Alright, great. So, we update our frame count. If frame count is equal to our delay or greater than our delay, we update our current frame, and then we just do a little balance checking. And then we set frame count back to 0, and then we just draw whichever image we're currently on. So let's go ahead and run. Look at that. Now isn't that spectacular? Granted, we don't have any motion. We can add motion, you know, but we don't have any motion just yet. And so that's looking pretty good, though. I have to say that's some pretty solid animation. And what the heck, we've got you here, I've got you here. But, you know, I hadn't planned for it. I'm going a little impromptu right now. But let's go ahead and add some motion, because I'm thinking if I'm going to do this, you know, might as well just do it right. So I'm going to come back up here. I'm going to create myself an x and y variable. I'm going to do int x, and I'll make that equal to width divided by 2. And I'll do int y equals height divided by 2. Great, great. And then down here in my timer, I'm just going to do x minus equals 10, And then I'm going to say if x is less than or equal to 0 minus al get bitmap width, and pass in. Since they're all the same width, no, just in case they're not, I'll do curve frame. That. Great. So then if it goes off the, oh, oops, it's the if statement, I almost forgot. If that happens, I'm going to set x equal to width. So it wraps around. So we're just going to have it, it's going to move from right to left and wrap around there. Basically just a little bit of error checking. Oh, am I missing? I am missing a parentheses. Great. So basically we're going to decrease our x value, so it's going to move towards the left hand of the screen. If it's less than 0, because remember we're drawing the bitmap relative to the upper left hand corner, so when it is off the screen it will equal 0, the left edge of the screen, minus the whole width. It will be completely off the screen. And if that happens, we're going to wrap it around to be just off the other side of the screen. And then I'm going to draw it at x and y. Alright, I'm going to go ahead and run this. And look at that. Oh, that looks good. Maybe a bit fast. That looks pretty fantastic, if you ask me. Let's drop that down a little bit. That was a pretty fast drag. I'm going to set that equal to 5. That looks a little bit better. Oh yeah. Now we're cooking with gasoline. Okay, so basically that is animation in a nutshell. Just showing one image after the next image, and when the image are changed just slightly, the eye is tricked into seeing, animation. It's tricked into seeing this motion that we're seeing on the screen here. Of course, we just had it very loose. By that I mean we just have some external variables managing our animation. In future videos, we are going to look at creating a sprite handler or a sprite struct that will kind of contain the image and all of its variables in one object, so that we can make animation for many different objects a little bit easier. But for now, you can play around with this and have some fun.